Find the length of the curve y equals x cubed over 3 plus 2x squared plus 4x plus 1 over 4x plus 8, where x is between 1 and 2. We have a formula for arc length, and that is the integral from a to b of the square root of 1 plus the square of the first derivative of the function dx. So the first thing we would need to do is find the derivative of this function. F prime x would be equal to 3 times x squared over 3, so x squared, plus 2 times 2x, so 4x, plus 4, plus, we could factor a 4 out of the bottom, and we'd have x plus 2 remaining, x plus 2 to the negative 1. So we'd have negative 1 times x plus 2 to the negative 2. We could rewrite this a little bit now. We could say f prime x is equal to x squared plus 4x plus 4 minus 1/4 x plus 2 to the negative 2. Now, something we might realize is that x squared plus 4x plus 4 is a perfect square. We could factor it into x plus 2 squared. Then we have minus 1/4 x plus 2 to the negative 2. Now we realize we have two terms with a common factor. That common factor is x plus 2, and we can factor out the least number of times that factor appears, which would be x plus 2 to the negative 2. Then we would be left with x plus 2 to the 4th minus 1/4. Now, according to the formula, we would square this. So f prime of x squared would be the square of this quantity. Now, let's see. We have two factors here, and the rule for raising a power to a power is that we would multiply exponents. So in the first factor, then, we would have the square of the derivative is x plus 2 to the negative 4, and then times x plus 2 to the 4th power minus 1/4 times itself, x plus 2 to the 4th power minus 1/4. Now we should multiply out the second and third factors. So we would have the square of the first derivative would be equal to x plus 2 to the negative 4 times, we'd have x plus 2 to the 8th power minus 1/2 x plus 2 to the 4th power plus 1/16. Now, if we were to distribute our first factor here through these three terms, what we would wind up with then is the square of the first derivative equal to x plus 2. When we multiply with like bases, we add exponents, so to the 4th, minus, now when we multiply x plus 2 to the negative 4 times x plus 2 to the 4th, we would have x plus 2 to the 0th, or 1, so 1/2 times 1, plus 1/16 x plus 2 to the minus 4. Now, the next part of the formula says that we should find the square root of 1 plus the square of the first derivative. And we have found the square of the first derivative, so this would be equal to the square root of 1 plus x plus 2 to the 4th power minus 1/2 plus 1/16 x plus 2 to the minus 4. But what we can see is that this 1 and this minus 1/2 would combine, and we would wind up with x plus 2 to the 4th plus 1/2 plus 1/16 x plus 2 to the negative 4th power. But this is a perfect square trinomial. We could factor this as the square root of x plus 2 squared plus 1/4 x plus 2 to the negative 2, and then that entire quantity squared. But of course, the square root of a square would just make the radical and the square go away. So we would have x plus 2 squared plus 1/4 x plus 2 to the negative 2. So now we need to construct this integral. So that arc length will be the integral from 1 to 2, x plus 2 squared plus 1/4 x plus 2 to the negative 2 dx. There are several ways we could go about integrating this thing, but one thing that would be really easy would be to make a u substitution. So if we were to let u be x plus 2, then du would just be dx. U of 2 would be 4, and u of 1 would be 3. So this integral then would become the integral from 3 to 4 u squared plus 1/4 u to the negative 2 du. This would then be 1/3 u cubed minus 1/4 u to the negative 1, evaluated from 3 to 4. If we go through the substitutions, this could be expressed exactly as 593 over 48. And if we were to round to 2 decimal places with an estimate, we'd have 12.35. So depending on the instructions in the problem, we could express our answer in either of these ways.